Okay, how's it everyone? Welcome. Just want to welcome everybody to this next webinar. As you can see, it's a bit of a cold day outside, or at least a slightly overcast and miserable day in Amsterdam today. And I just arrived basically yesterday back in Amsterdam. At least it's green on this side of the world. And I just want to say again, thanks to everybody who is joining us today. I see we've got quite a big turnout. And I'm very, very pleased to be presenting to you guys today. We're going to be doing a deep dive into the clean architecture as part of today's workshop. As part of the session, we'll basically look at a clean architecture in .NET, and we'll be unpacking all of the different components within that, and really some of the advantages, of course, of the clean architecture, why we do the things that we do, as well as some of the nuances that exist within the way that the clean architecture is implemented in .NET with a set of patterns that Intent Architect is essentially bringing to the table. And we'll run you guys through that in a lot of detail. And along the way, I just wanted to mention that you guys are very welcome to drop questions into the Q&A. The chat is enabled if you do want to chat to some of the panelists. Basically, I have a few of the guys on the team, a few of the architects. You guys will probably know them. It's John, Joel, and Dundre in the background, and they'll answer your questions. So if you guys do have any questions along the way, you're welcome to ask them there on the Q&A, and they will respond, and that'll be there for everybody to see. I do also want to just mention that at the end of the session, I do want to do a Q&A. So if you do have questions that you'd like to raise and you'd like me to answer them, we can spend the last 10-15 minutes at the end of the session going through that. So yeah, looking forward to it. And I think without a further ado, very happy to jump in. So really just to give you an idea of how we want to go about this, I'd like to just share for those of you who are not necessarily 100% familiar with the clean architecture, I want to give you a little bit of background. That's where we're going to start, a bit of the conceptual sides of things. We can then get into some of the benefits of the clean architecture. So essentially, what are some of the non-functional requirements that it's aiming to achieve, and how does it manage to do that? Then what we can do is we can jump into Intent Architect, we can get a clean architecture on the go, and that's when we'll really start getting into the detail of it. And that's really the meat of what we're going to be talking about today. Okay, so I think the first thing I want to do is just quickly share a presentation that is running at the moment. Just give me a second, I'll get that up. All right, so the first thing that I wanted to throw up here is that this is the clean architecture in the Uncle Bob style of presentation. So if you go Google out on the internet, clean architecture, you'll absolutely find this article, or at least an article that has a diagram that looks something like this. Obviously, we've just brought it into a slide deck on our side. There is a link at the bottom there to the official clean architecture by Uncle Bob from back in 2012. Now, the one thing that I can mention here is, and this is the most important thing, is that the clean architecture fundamentally is really about a set of dependencies. So how are things related from a dependency perspective? And if you look at the diagram, we've got a set of entities in the middle. This is where essentially the idea is that the enterprise business rules will exist in the middle of the application. You've got the use cases, which are the application business rules around that, and that is depending on these entities. Then we've got the interface adapters, the things like the controllers, the gateways, the presenters. Essentially, these are adapters that exist around that, and the dependency there is on the use cases. And then finally, we've got, you could say, our frameworks, right? So these are the web frameworks, the technologies that we're using, the databases, and so on and so forth. And so the whole idea here is that the dependencies are moving inward, and that the inner dependencies are not aware, you could say the inner concepts or the inner concerns are not aware of the outer ones. And that's a very, very key concept here. It does also help to understand that when Uncle Bob looked at setting up this clean architecture, it was really bringing together the different other types of architectures that achieve very similar things. And this is his attempt at bringing together the concept into a singular diagram. And this is essentially what he set out. But very similar architectures are things like the hexagonal architecture, the onion architecture, and others. And if we took a look at just a hexagonal architecture, it is very much the same thing, just expressed slightly differently. So of course, the nuances of each of these architectures is a bit different. But at the same time, the principles, and especially the principles around the dependency, is exactly the same. So in the hexagonal architecture, we talk about a domain model in the middle. That's also where the enterprise business rules will live. You've got the application services, which is essentially your application layer around that. And then we've got all the adapters that are there to connect us with other framework-related components. So things like certain clients in the equation. So this could be databases, it could be our UI, it could be buses, and so on and so forth. And these are all handled by the adapters. And just to give you one other example here, just to kind of really give you a feel for how these all fit together, is if we took a look at Microsoft's DDD-orientated microservice architecture, it is exactly the same principles. They do simplify a little bit in the Microsoft way that they like to operate. And so we've got the domain model in the middle. We've got the application layer depending on that, and we've got the infrastructure layer depending upon that. And then what they like to do is they like to say that the application layer depends on the infrastructure layer, and that's technically not correct from a clean architecture perspective, but Microsoft does tend to encourage guys to write a lot of their business logic directly against entity framework and so on and so forth. But that's why I've highlighted, if you look on the right there is a use repository implementation classes, ideally through DI. And if you manage to do it, put the interfaces in the correct place, so your repositories or your services from your infrastructure layer in the application layer, those interfaces are there, then you would invert the relationship. But just to keep true to the original document, the original article by Microsoft, we just decided to keep this dependency that way around. But just keep in mind that that wouldn't technically be correct in the clean architecture way. So when we take a look at the clean architecture, the dependency rule really allows us to do quite a few things. And all of these architectures that we've discussed, so the hexagonal architecture, the onion architecture, Microsoft's basically, this is a layered architecture that they've put over here, but this is really around their DDD-orientated microservices architecture. One thing I wanted to mention is that DDD tends to follow a lot of these principles too. So while DDD is not a requirement for the clean architecture, it fits in very, very nicely with the approach. And DDD, in a lot of senses, is quite a purist approach to building out software systems in an object-oriented language. But let's just talk quickly about what the clean architecture brings to the table and why we ultimately want to use it. And so all of these architectures that we've discussed, the clean architecture, the onion architecture, the snowman architecture is another one that has very similar principles. All of these bring forth a set of very important features, essentially. And so the first is that we get independent, we basically build the systems that are independent of their frameworks. So the architecture no longer depends on the frameworks that are being used. That's very important. It makes them testable. So this is basically because the business rules are independent of the technologies, because if you remember that the domain and the application layer aren't aware of the outer rings in that original diagram. We're also able to get these independent of the UI, so we can change the UI quite easily. And an example that, if you take a look at the Uncle Bob document, he gives the example of replacing the web UI with a console UI, or having both. And that shouldn't affect the architecture and the business rules of the system. It also allows us to build our systems independent of the database, all right, or any infrastructure for that matter. And so the business rules are not bound at all to the database. And so you can, in theory, swap out, for example, an Oracle or SQL Server database for a Mongo Cosmos. That is sometimes a little bit of a stretch, in my opinion, just because oftentimes when you do design databases, for example, in a relational database, or if you design the database in a document store like Mongo Cosmos, the approach that you'll take is quite dramatically different in terms of your design. So it's a bit of a stretch, but it's not impossible to achieve this, depending on the complexity of your system. But the principle is there, and in theory, you would be able to make this kind of swapper if you really wanted to. And then finally, this also allows us to build systems that are independent of any external agent. So we've talked about the database, the UI. These are actually really just external clients, or at least providers, technology providers for the system, and external agencies could be integration points and so on and so forth. And so because the business rules don't know anything about these, they're just talking to interfaces, how these things are implemented, the systems can essentially evolve independent of all of these external agencies and services and things like that that they're connecting to. So what does this ultimately lead to if we were talking about the non-functional requirements is, as you can see, that because we're building everything in such an independent way, it's already mentioned there, but we've got testability but maintainability is very important. One of the major non-functional requirements of this. If you're building larger systems, the clean architecture really brings to the table the ability to have very, very highly maintainable systems in the long run. All right. So that's a very big component. And of course, as part of that, it allows them to remain flexible. So you can see how a lot of the examples that that Uncle Bob gives as part of this is swapping things out. That is really the idea, but it's also allowing us to evolve those technologies independent of the business rules and make sure that our system is tested, at least when it comes to the business rules, those are tested irrespective of the frameworks they were ultimately using. All right, so that's really the high level of the clean architecture from a theoretical perspective. Of course, there's a lot more reading one could do on that. These links, obviously, they'll be here, and this webinar is being recorded. And so you will be able to jump onto those links, and I'm sure you guys can do a quick Google if you're interested. The principles here are very, very key in building software systems that have to last, that have a long shelf life, that need to be maintainable, that, you know, there's new business rules. The clean architecture really excels at those kind of systems. It does, you know, if you had to say what is the downside of clean architecture, the one downside that it does have is that sometimes for developers that are not familiar with it, it has a little bit of a learning curve. It's not a big learning curve at all, but it does have a little bit of a learning curve. Other than that, it is all pretty much upside. And of course, there's a cost to any architecture as well. So it is a slightly more complicated architecture. You can fathom easier and simpler architectures too, but it does, because of the benefits that it brings to the table, the testability, maintainability, and flexibility in the systems, it really is a fantastic architecture. And we've seen many, many successful systems and large systems, in fact, built in this way, including microservice architectures and following DDE and so on and so forth. Okay, so what I'd like to jump into is I'm going to share my desktop, and we can jump into actually setting up a clean architecture, a real world clean architecture. So just give me a second, I will get this shared. And that should just throw up my desktop there. And I'm going to launch Intent Architect. Let's just jump to the other monitor. All right. Okay, so if we wanted to get a clean architecture in the mix, we have a standard clean architecture in .NET application template. We're not going to focus too much around the intent architect related aspects as part of this webinar. It's really just a deep dive into this clean architecture. But of course, getting us set up and getting us there very, very quickly is best done with, well, it's very easy to do with intent architect at least. So if we wanted to, we could create something called webinar. I'm going to create something called invoicing over here. So let's say we wanted to create an invoicing application or an invoicing microservice per se. We can go ahead and create that over here, and we can call the solution name just webinar. And before we jump into actually creating it, we can just talk through the different patterns that make up this architecture in .NET. So at the top here, we've really got, and this is infrastructural. So this is actually part of our framework set that we're using. We've got the ASP.NET Core. This is for our controllers, for essentially for our RESTful services, as well as for the startup of our application and the hosting of it. We've got the JWT bearer tokens for authorization authentication. We've got Swashbuckle for the open API. And then we get into our application layer where we're using a mediator pattern. Now, the mediator pattern is not a requirement of the clean architecture, but it is a very common pattern that we see when teams build out clean architectures, because it really allows us to achieve amazing separation of concerns in a way that's very difficult to achieve if you are doing it without something like a mediator. So when we get into it a little bit deeper, I'll show you guys exactly how the mediator works and how the pipelines are set up. But what it allows us to do, if I could just give a 1-minute overview, is it allows us to essentially build a pipeline. So whenever you want to dispatch a command or a query, which is generally the approach that the mediator takes, but any kind of request into the system, you would pass that through a pipeline, which is set up and implemented in a cross-cutting way for the mediator. And so this allows us to put in all of these different cross-cutting concerns, things like transactionality, units of work, we can have security and so on and so forth, all existing inside of our application layer, which ensures that those aspects of the system are ensured as part of any request that comes into the system. So it keeps the separations very, very clean, and it also allows us to not repeat ourselves. So if we didn't have the mediator pattern, we would have to build these kind of cross-cutting concerns. We'd have to build them into our middleware on the ASP.NET Core. And then, of course, that wouldn't exist if a message came in from our message bus into the system. And so we would have to re-implement it over there or find a way to reuse that, where the mediator allows us to do this without having to essentially repeat ourselves. So it's a really fantastic pattern, and one that once one wraps their head around it, it's an excellent way for us to ensure that every single time we make a request into our system, that certain cross-cutting components are covered and that there's no mistakes. Then the other pieces of the or other patterns that are employed here, we've got AutoMapper, just for mapping out the domain entities to the DTOs. Now, one thing I can just mention on this is that we never, when it comes to technologies like AutoMapper, you do not want to map your inbound DTOs onto your entities. Okay, the way that this is set up and the way that the pattern is created inside of this architecture using these patterns is that the AutoMapper will really only allow you to map domain entities into DTOs, but not vice versa. And that's very intentional. We have seen teams that will go and use AutoMapper to, in fact, automap their DTOs onto their entities. But in a lot of senses, that can be incredibly dangerous, and it can, in a sense, also cause a lot of bugs. It's also it's very risky if you've ever had a bit of an experience with AutoMapper where it's dealing with collections. So we really do not recommend taking AutoMapper, even though you can, to take AutoMapper and allow it to map inbound DTOs onto the entities, because it is extremely risky and can cause all kinds of bugs in your system. Collections are just one example. Of course, you could automatically set things that you really didn't want to set if the DTO has information on it that that was lying around. For example, maybe it wasn't on the front end, maybe that field wasn't displayed on the front end, but it was on the DTO, and so a hacker could exploit that, just as a simple example, and AutoMapper would apply it straight away. So you want to be more deliberate, even if you're using an anemic domain approach as opposed to a rich domain approach, more like DDD. Even if you are using an anemic domain approach, which is what the example we'll run through today, you still want to control that business logic very explicitly. So that's something I can just mention on that for anybody who is considering using AutoMapper to do the inbound mappings. We don't recommend it. You can absolutely do it, but it's very risky, and we've seen a lot of mistakes, a lot of bugs come out of that approach where we do come across it. Fluid validation, of course, any system you want to be able to do some basic validation of your inbound requests. Of course, CRUD support is part of the standard intent architect set of patterns just for automating the predictable repetitive CRUD work. Pagination, entities, these are, of course, patterns that you will need for any system. Value objects and domain services if we were doing DDD. Domain eventing, we'll keep that in place because we want to talk about that a little bit. This is not really a requirement of DDD, but it's a fantastic pattern to ensure that we don't have to write the same logic into our handlers, our command handlers or query handlers, typically command handlers rather, because this will really be orientated around the mutations in the system. But it can really save us from having to write the same logic in many, many places. It can ensure that things always happen and guaranteed to happen because we can essentially event them out of the domain. You will absolutely see a pattern like this if you're dealing with DDD, but it is a great pattern nonetheless, even if you aren't. All right, so and then the last few things that we've got here is we've got going into our persistence. This is essentially infrastructure. We've got entity framework core. This is for persisting. This is the ORM. Everyone's probably familiar with this, but this could easily be a Dapper. It could be the DAPPER version of it. And this could easily be a Mongo and so on and so forth. So it really does. The Cosmos DB is totally fine here as well. We could have any persistence, but this is all as part of the infrastructure. And we got a repository pattern here. Now, one of the reasons why you'd want to bring in a repository pattern, just generally speaking, is that a repository pattern ensures that we are not coding against our database technology. All right, it means that we're coding against an interface, which is the repository, and that the repository implementation, which would exist in our infrastructure, as we'll see shortly when we jump into the actual code, that implementation will have all the technology related nuances, but the application layer and the business logic written in the application layer will be doing it against an interface, and that makes it testable. And it means that if we do ever need to evolve our technology layers in the persistence, whatever that may be, whether it's actually going as dramatic as swapping out an entity framework for a MongoDB, if we wanted to do something as dramatic as that, we can actually achieve that. All right. Not something that, as I mentioned, you would do easily, especially in an existing system, just simply because relational databases are oftentimes designed quite differently to document stores for many reasons. And then, of course, we can bring in mass transit if we wanted to do pub sub. And if we need multi-tenancy, we could bring in Finbuckle, but these are just additional. You could say this is an additional adapter. That's an additional adapter in the system. If we're thinking back to that hexagonal architecture, the ASP.NET Core is essentially an adapter. These are all part of the framework layer and the technology layers of our application. Okay, so if we're happy with this, we can say create, and we can just get this installed. And while we're waiting for this, we can just watch it install over here. I'm just going to bring that across. So we're just getting some warnings here because as we've released version 4 of Intent Architect, which has come out very, very recently, I'm sure you guys have got the email. There are some modules that still exist that are saying that they are not compatible with version 4. So what we want to just quickly do here is, I think the application template is essentially just waiting for an upgrade, but we can hop into our updates and give that a second to load. And once that's done, we can just update everything. And this will make sure that all of our modules, so these little warnings here that we're seeing is essentially saying that those modules are not compatible with this version of Intent Architect, even though they are, because version 4, if you guys recall, is compatible with version 3. But when we set up the modules, we always lock out the next major release because we are anticipating that there will be breaking changes. But it just so happens that with version 4, we kept everything fully backwards compatible with version 3 modules. So that's why that is showing up the way it is. All right, so what we can do here is we can just start rolling out this application very quickly. So I'm going to go ahead and design it. We can create the code base in a second, but because this is an invoicing application, we can go ahead and create the concept of an invoice. Let's actually just center this over here. We can have an invoice. We can also just have an invoice line. We'll just need a product maybe. We just need to get some stuff here so we can work with the system. Maybe we'll need a customer. We'll also need an address of where that customer is, the billing address and so on and so forth. Can drag that in. Customers over here. And we can essentially just fill out a domain. So we just want to have something in the system for us to look at so that we can reason about the clean architecture at a high level. So I'm just going to fill this in very quickly. So we're going to have a one-to-many relationship over there. And we're going to have a many-to-one relationship over here. So each invoice will have many lines and each line will point to the product. We can have the invoice will have a customer that it's for, and of course we can specify the address. And one of the things we would typically see in a system like this is you would see maybe this address would be a billing address, for example, and then maybe you'd have another address over here which would be the delivery address. And it could happen that you may have a delivery address. We'll fall back on the billing address rather, and we'll just make those one-to-ones and one-to-zero-one relationship like this. Okay, so this is our domain. If we wanted to just fill a few things in, just so that it's got a bit of meat, let's just fill in the customer. So name, surname, email address. I'm not sure what else we could put there. Product would probably just also need a name and a description, and you'd probably have some kind of like a URL, image URL, potentially in the system. I'm not sure. On an invoice, you never know. Maybe the company wants to actually show the picture of it. An address would maybe have a line 1, line 2, a city and a postal code, and so on and so forth. And the invoice would probably have a number, right? Which can be an integer if we wanted it to be that, and a created date. It could be a date time. All right. Last one thing here, just for completion's sake, let's put in the quantity, which can be an integer, and then we'll have the amount, which would be a decimal if that was, or we can actually make it a money type if we really wanted to. All right, so that's our domain. Let's just actually kick off the software factory, get this generated. So that's just going to go and put that in place, and then we can hop over to our services, and let's just go and use this accelerator here for the CRUD systems to create a customer. We can go ahead and do the same for the invoice. And you can see we're really just targeting all the aggregate routes here, essentially. I'm just going to create all of those, and that'll basically set up all of our different endpoints so that you can see we're getting these aren't the endpoints, these are the commands and the queries themselves. If we wanted to get the endpoints in here just in terms of the controllers, let's just go, we can basically say expose as HTTP endpoint or Control-Shift-E. I can just use that shortcut there. and that'll just go set up the controllers for us very quickly. All right, perfect. So there's our controllers. We can apply that, and this is just getting our application very, very quickly set up. We can go and open up the location over here, and we can jump right into the code base. All right, so give Visual Studio a moment. All right, so the most important thing here is, first and foremost, you guys will notice that the structure of this application is set out. And for those of you who are very familiar with the clean architecture and intent to architect, you'll know that the structure is really set out by default inside of this Visual Studio Designer. So we've got the different, and we can see this actually in the actual Visual Studio over here, but we've got the different layers, so to speak, or the different rings, essentially broken out into different projects. That way we can be 100% certain as developers that our domain, for example, does not have any dependencies. So if we take a look at the dependencies in the domain, we'll see that there really is only the Roslyn Weaver attributes, which, as we all know, is not a dependency, a runtime dependency at all. It's just metadata for the code management systems. But this is essentially, there's no project dependencies, there's no NuGet dependencies on any kind of framework or infrastructure that's required. And so this is completely technology agnostic. And if we were doing DDD approach, this layer here would have, or this project over here would have pretty much all of the rules within our system from a domain perspective. Okay, so all of the enterprise rules would essentially exist inside of our domain over here. If we are doing more of an anemic approach, the application layer would probably have most of those rules. So it really depends. In DDD, a lot of the rules would go in here, and in an anemic approach, those same rules would exist inside of the application layer alongside all of the other, you could say, application layer rules. Okay, so the application layer rules are, I think of this like the verb layer. It's like, what can you do to the system? You can create invoices, you can get in, you can view the different invoices, you can create customers, you can create products, and so on and so forth. And those are the things that we can do to the system. The rules around that would exist within the domain. But if we took a look at the application layer over here, you would see that from a project perspective, it once again depends only on the domain. So this does not depend on our infrastructure. This is really what I was saying in terms of the Microsoft approach, where they were saying that this layer here does in fact depend on the infrastructure. They did write there that you are ideally using dependency injection, and if you put your interfaces in the correct space, you won't need to create that dependency. Rather, it'll be the inverse of that. So we're basically doing an inversion of control here, and so what we can see is that this is also as technology agnostic as we can get it, because we've also got these are very lightweight frameworks, and these aren't essentially, the way I distinguish between these is that these are not adapters to any kind of third external database or external API or client or agency or anything like that. These are you could say they're C# libraries that have no other dependencies besides themselves, okay, or at least the dependencies that they have will be to other C# libraries that don't have connections to other technology. And so things like AutoMapper is really just an accelerator, right? That's really the idea here. Is it's an accelerator. It isn't something that is required. We could always write out the mappings ourselves, but this is an accelerator. Fluent validation is a very succinct way for us to reuse a validation system and keep a great separation of concerns. So that's why fluent validation doesn't really count as a technology dependency per se. MediatR is really just the system which dispatches our commands and queries or any kind of request over to the handlers. And so once again, the distinction here is that this is not trying to connect to a database. It's not trying to connect to a third-party API. It's not actually using any technologies per se. These are coded in vanilla C# without any dependency on any kind of third-party frameworks outside of themselves, okay? So it's a little bit of a subtle distinction, because things like Entity Framework is very much a technology which is talking to databases and other resources, essentially. I think that's maybe the best way to describe it, is it's talking to other resources. And that's what we do not want to see in here. So we don't want to see any very heavy duty technology. And these are really very lightweight and very focused around making our lives easier inside of the application layer, but are definitely not requirements. Okay, so this is the application layer, that's the domain. We've got the infrastructure. Now, this is quite interesting, because what you'll see here from a project perspective is that this is depending on the domain and the application. And the reason that is the case is because we've got this inversion of control. the infrastructure is essentially responsible for implementing a lot of the interfaces that would exist between the domain and the application layer. So the interfaces exist, for example, of the repositories. These exist in the domain, okay, just as a set of interfaces. They're completely technology agnostic. So you can see that they've got, we're just talking about products, which is inside of the domain too. As you can see there, we've got the general repository over here with, as you can see, all of this is completely technology agnostic as well. And so all of these interfaces, while they exist in the domain, are actually being implemented inside of our infrastructure. And we'll go through that a little bit later, okay? But the most important thing here is that the domain and the application layer do not depend on the infrastructure. It's actually the inversion of that. And that way, we've actually set up our application and domain to be very, very testable. Because one of the challenges that you will find is that if you connect everything to the infrastructure, you can't write tests for those systems without actually either mocking out or running that infrastructure. Ideally, the interfaces allow you to mock that infrastructure out, which is exactly what we've got over here, because we don't have a dependency on the infrastructure. We've got a dependency on the interfaces. Okay. The other things that we can see here is just in terms of the packages is here we see very more heavy duty technology. So mass transit, this is for a bus. So once again, we've got an external resource that we want to be talking to. So this is definitely part of our technology layer. We've got entity framework. This is also, talking to a database. Could be talking to a SQL Server or an in-memory database, or it could be talking, in this case, it's talking to an in-memory database, as we can see over there. But it could easily be talking to even Cosmos, if you guys are not aware of that, but Entity Framework can also connect to Cosmos. But we could be using Postgres or SQL Server or MySQL or any of those as well. And then finally, the last thing we can see here, just in terms of the API layer, okay, this is essentially our distribution layer, and this is also a technology layer because it will have dependencies. Let's just take a look here. It'll have dependencies on our application and infrastructure, all right? So therefore, by extension, it would have a dependency on the domain. But one thing that you saw earlier is that we were talking about DTOs and entities and automapper. You do not want to send your entities over the wire. What I mean by that is that you never want to pull your entities out of the database and just send them through your controllers out to the world. That is a bit of an anti-pattern, and there's many reasons for that. The first is that, of course, depending on what you're pulling out of the database, and how it's been structured. So if entity framework's there, you may have lazy loading. You'll end up essentially serializing a lot of your database in one go. All right, so that can be very bad from a performance perspective. You're also you could accidentally expose a huge amount of data which you never intended to expose, and which would obviously be very bad as well. And then you can also end up with, depending on how your domain is structured, you could end up with cyclic references for the JSON. Okay, for whatever serialization technology you're dealing with. And so that's another reason why it's just an absolutely terrible practice. We do see that quite a lot. Microsoft actually did suggest a lot of those approaches. And the reason that Microsoft does that, we believe, is just because they try to make it as easy and as simple as possible to use their technology set, even if that means that what they start recommending out the box is a set of bad practices. So you can't really build large enterprise systems that are very robust and bug-free, or at least have very low bug counts as they evolve, using the principles of sending entities over the wire and things like that. But that said, I'll just mention that you can still do it and you can still build a system. It doesn't mean that you can't achieve building software if you do decide to actually send your domain entities over the wire. We would just consider it a very, very bad practice and something that we wouldn't recommend for, or something that we would at least recommend against. All right, so let's just take a look through the last thing here. I was just about to jump into the controllers, but before we go there, I just wanted to point out that we do have these dependencies are the project dependencies, and then above this, we've essentially got ASP.NET Core coming in as part of this, and the ASP.NET Core is essentially going to bring in a lot of our, we've got the standard dependency injection, we've got all of the different, the middleware for all of that, as well as the systems which can essentially convert our control, will handle all the incoming requests through the controllers and so on and so forth. So this is absolutely part of our technology layer. We could have swapped this out. If you want to think about the clean architecture in this regard, you could be building this as a WCF application. Not that anyone does WCF anymore, but we've got RESTful API over here. We could have decided to switch over to a GraphQL API or a gRPC API or any of those things, or have all of them at the same time without actually changing the application and domain. Okay, similarly on the infrastructure side of things, as we discussed earlier, we could swap out the entity framework for a MongoDB or a Cosmos DB or a Couch DB or any of those, and we would not have to change our domain and application layer because they are completely independent of these technology layers. Okay, so I think that is hopefully very clear at this point. What I'd like to jump into is let's start going through this application from top to bottom. That's the way that I like to go about it is, if we took a look at the startup, so this is a very standard startup. We don't need to spend too much time here. It's really configuring up the services and configuring up the pipeline. Okay. All of the different configurations would be listed over here. So this is just for our security and our swashbuckle. The different dependency injections are dispatched. So this will be inside of our application layer. Okay, so there you can see there's the dependency injection for our application layer. Excuse me, and this is the dependency injection for our infrastructure. Okay, so this is really a startup. It's very, very straightforward and simple. Of course, any other components that we wanted to bring in over here, or services, we would probably want to, depending on what they are, you'd want to do a very similar pattern of dispatching them into different configurations and just registering up a one-liner in this place, okay, in this file over here. But really, if we had to get into how this architecture functions, we're going to have to take a look at the controllers. So if we took a look at the customer's controller, just as a simple example, we've got a mediator, basically the iSender. This is a shortened version of the mediator interface. So it's just got the sender on it, which is essentially .send, okay? And we're injecting the mediator in. And then whenever we get a request in over here, so we can see that if we had to do a post on API customers, okay, so this would be the customers on the customer's controller, essentially, we would see here that it would go and take the command, which is, in this case, our create customer command, which is the payload, okay, comes from the body, and it would just dispatch it onto the mediator. And that's exactly what you'd like to see in a controller is you want to see it just do its function, which is receive the HTTP response, convert it into objects that we can actually work with, and then we want to dispatch it over to our business logic, and we're doing that with the mediator pattern. If we weren't using a mediator, we would maybe see something like an application service over here, so some kind of a iCustomers service, and that would be injected over here, and we would probably dispatch onto a create customer directly. But I'll show you guys as we get into the mediator a little bit the advantages of taking it through the mediator as opposed to a much simpler interface dispatch. And yeah, so we'll talk about the different approaches there as well. And then once we get our result back, we just essentially return some kind of an HTTP response over here. And as you can see, there's our 200s over there. We've got, if there's some basic high-level validation that we're bringing in here for a bad request, return a 204, and so on and so forth. So this is very, very straightforward. Now, how it works with a mediator, just in case anybody on this call is, or on the webinar today, is unfamiliar with the mediator, when you say send on a command, and we can go to this command quickly so we can see what it looks like. It just needs to implement this iRequest and what it returns. This interface here, we're going to circle back to a little bit later, but it's a very, very important interface for ensuring that the unit of work happens for any kind of command. And then we just see this is the fields. And if we find this location in the code base, you can see that right next to it, we've got the handler. Now, the handler over here is what the final destination is for this request, okay, for this command. If it was a query, it's for the query. So whenever you say mediator, so if we hop back into our controller, whenever you say mediator.send command and you pass in the cancellation token, you're ultimately going to end up over here, unless something breaks along the way, which we'll get into shortly, okay? So we would get into this code over here, and we can inject whatever we need in through the dependency injection. So here you can see we're just injecting in the repository, and we're just going ahead and auto-implementing this because it's very clear what the user wants to do based on the design that we put forward, and that is that they want to create this customer. Little subtle nuance over here is you can see that we're actually on the repository, we're fetching out the units of work and actually calling a save. That can interest some people. The reason we have to do this in this particular circumstance is because the database is responsible for generating the identifiers because we're using GUIDs by default, but if we're using integers, it would be the same story. And so the current set of patterns is ensuring that has delegated the database to be responsible for setting out the identifiers. And so we need to actually save this entity before we know what the ID is. So that's why this is automatically implemented over there. Typically, you would not have to do this, and I'll show you why as part of this architecture. If we jumped into the dependency injection, we can start seeing some of the nuances of the mediator. So when it comes to the mediator pattern, at least this is the Jimmy Bogart style, okay? That's why it's MediatR, that's his library. What you can set up is you can set up a set of pipeline behaviors. And this is the pipeline that I was referring to earlier. And the order in which you register these is the order in which these will be executed. And you can see here that we've got several behaviors that have been registered as part of this. So if we just talk about them very briefly, we've got an unhandled exception behavior, we've got a performance behavior, an authorization behavior, an event bus publishing behavior, a validation behavior, and a unit of work behavior. Okay, so these are all each of these are quite interesting. Some of them are more geared around logging, others are geared with some of the non-functional requirements. But here we can see, for example, that if we have an exception, so this is how a pipeline behavior would work, is when it handles itself, it's essentially a chain of responsibility. It can pass on to the next pipeline behavior. And if there are no other pipeline behaviors remaining, it will end up in the handler, which was this file over here, if you recall from earlier. And if we have an exception, as you can see from this code, if we have any exception, we're just going to go log this error in the logs. All right, so you could have any sync. We're using Serilog in the background. So this is the Microsoft standard logging, and then Serilog is essentially adapting to this. And that you can have any sync for that. You can have a console sync or a database sync or a log file sync for Serilog. You can set it up to application insights and so on and so forth. So we would just see that this error was in fact logged if we get any kind of unhandled exception at this level. If we hop back, we can see that we've got performance. This is another logging behavior. So what it's doing is when it comes to the handle, it's starting a timer. It's basically passing it down the chain. So onto the next pipeline or finally onto the handler. And then when it gets back here, once this comes back, because as you can see, we've got an await over there. Once this finally comes back, we're going to stop the timer. We're going to fetch out the elapsed milliseconds. And if it's longer than 500 milliseconds, we're going to just log a warning to our logging system, whatever the sync is. We're going to log there that there is a long-running request, and this is an indicator when we see these warnings for the developers that they may have performance problems within their system. So this is just something that you'd see that's very standard as a general way to notify developers that they do in fact have some kind of a performance problem. I mean, you shouldn't have any kind of query in your system running for more than 500 milliseconds, ideally. All right, so then next in the pipeline is part of our security. So this is quite interesting because, and this is very vanilla for an authorization behavior as part of a pipeline. I think this code came out of a fantastic sample that that there was on GitHub that we found. So obviously, as part of the research that our team did when analyzing the clean architectures, we went through multiple samples on the internet, taking a look for what made the most sense. And we did find some really fantastic ones, and we also found some absolutely rubbish ones. But this came out of one of the fantastic ones. And this is essentially just responsible for handling it checks on the request type whether there is an authorization attribute. Just to show you here, how we get that set up is if, for example, we wanted to authorize the create, we could just apply this authorize over here, and we could specify its role or its policies depending on how we've implemented our system. And what this would do here is, let's just get the software factory to run, is it would go and add this authorize on top of the command over there. Let's just go maximize this so we can see it. So it adds that over there, and it's also going to go onto our controller and actually make sure that that is now authorized, so that we do in fact ensure that the security is applied across both at our infrastructure level as well as on the command itself. And if we just come back here, we can see it there. There's the authorized behavior. This is basically detecting that. It's going through and finding out whether there's a role on it. If there are any roles, we go and validate those roles against the current user service. This is an interface, as you can see over there. We could implement this with any kind of, so if it was, we can use the principal claim system or any kind of system to implement this current user service. And if it's a policy-based approach, then we just delegate it over to the authorize against this policy. All right, so either approaches are supported as part of this. You could either do roles or you could do policies. So that's what that behavior is essentially ensuring happens. And what's great about this is that this means that the security, regardless of whether this comes in through an HTTP response or if it came in through a gRPC request, HTTP request or a gRPC request, or it came in through a message from the bus, if this request if there is a request that's coming through the mediator that does have an authorized attribute on it, we can absolutely guarantee that we're going to check it properly. So we don't have to write all of that security logic into every single one of our infrastructural components. All right, then after this, we've got there's kind of two interesting ones here. There's the event bus publishing behavior and the unit of work behavior. Before I look at those, I want to just quickly look at the validation behavior. So the validation is really just coming in here. You can see what we're doing is it's essentially for this request, it's injecting in the validators. So this is just very, very neat way of doing it. We can just check if there are any. If there are, we can go and essentially run them. Okay, they are asynchronous. Okay, it's because sometimes some validators you may need to hit the database. This is an example of the validator over here. So this validator, we're just still looking at the create customer command. This is just really just checking that the name, surname, and email address are not null. Okay, that's because that's how we set out our design. So if we look at our design over here, these are all not null. Okay, and if we were to enforce certain constraints in the database, these can actually be enforced here automatically as well as part of that. And so what's happening, let's just hop back into that validation behavior. So what it's doing is it's getting out any validators like this one, for example, and it's running it. And if there are any failures, it will throw a validation exception. And this should ultimately be handled by the infrastructure. So for example, inside of the ASP.NET Core, this will this should get converted to a 400. I did a presentation on the clean architecture very recently at one of the development houses that we work with, and they raised that we actually have this is not being turned into a 400, and that's something we are aware of. And I think that we have a pattern that either has been released or will be released, which is essentially does handle this exception as part of the middleware on the ASP.NET Core, and convert that into a 400 in a very clean format. So if that's not out already, I'll just have to check with the team. But if that's not out already, it will be very, very soon. And then what we do is we pass it on to the next handler. And ultimately, as I mentioned earlier, it would ultimately end up here, which is where we'll handle the business logic, and it gets passed back up. The most important thing here is that, as you can see, the separation is very, very clean. We do not have to worry about things like writing our validation code in here. We don't have to worry about putting in logging. We don't have to worry about checking for security and so on and so forth. All of that stuff is automatically, we know that it's going to happen. So the separation of concerns is very, very clean. And the way that it's structured is very neat. And so that's one of that makes this very testable, firstly. So we're able to test just this logic without getting caught up in, validation errors and things like that. And we can test the validators separately. Okay, so we can throw the validators through a very strong set of unit tests to make sure that all of those edge cases are covered, independent of the actual business logic that we want to write as part of that. Now, validations would count as business logic, and so would mappings to some degree. So you would want to test these. You would want to test these across the system as you build out your unit tests. But the two that I missed here was the event bus publishing and the units of work. Let's just take a look at the units of work quickly. So the units of work is what it's doing here is at a high level, it's just creating a transaction scope. Now, this is very important because if you're familiar with, let's just take entity framework, for example. Whenever you call save changes in entity framework, if you call save changes as part of a call to your system, so there's a request that's coming in and you make some changes to an entity and you say save changes, and then you make some other changes to another entity and you call save changes. Each of those calls will result in a transaction inside of your database, typically speaking, if you don't do anything else. And so that can create a transactional concern because, of course, if the first transaction completes successfully and the second one bombs, you've actually gone into an invalid state in your database. And that's something that you absolutely want to avoid. And so what we prefer to do here is we prefer to actually move that out into, so Entity Framework does implement a unit of work pattern by default, okay? And what that means is that as you're making changes to your entities and you're saying, well, this entity maybe needs to update or this entity needs to be added, what it's doing is it's actually holding on to all of those changes, tracking them to some degree, okay? Entity Framework is a fantastic entity tracking system, which can really simplify a lot of your business logic code, but you can also switch it off. What that does is it delays the execution of those inserts and updates to when you call save. All right. And why this is very, very important is because when it comes to databases, especially relational databases, there are locking systems in play that can have a massive and dramatic effect on how your system's performance is managed. Okay, so when we take a look at the transaction scope, and I'll talk about that briefly, you'll see that there's an isolation level of read committed. Now, if you're not familiar with isolation levels, you can take a look into them. If you are building your system in a relational database, you absolutely want to familiarize yourself, at least with the general concept of isolation levels. It's not something that's a big concern if you know that, I'll just say that read committed is pretty much the best compromise you're going to get from an isolation level. But what you don't want when you're building a system is you don't want to escalate locks and hold onto them for the duration of the transaction unnecessarily. So to give you an example, if you have a much more stringent isolation level like serializable is the most, let's just see what the option is here. It's called serializable, that one there. What this does is it basically says if you read any data out of the database, when you read that data, it will create a lock, a read lock on that, potentially on that record, on that index, or on that entire table, depending on how the table is structured. That read lock will be held for the duration of the transaction, and so no one else is allowed to write there. Maybe other read locks are able to come in, but no other write locks are able to access that record, and so you have a bottleneck in your system. All right. Write locks are also held for the duration of the transaction. And so if you try to set your isolation level to serializable, you're going to very quickly end up with deadlocks, okay? Because you're going to have two transactions, both of them start holding reads. They both want to write to each other, and you end up with a deadlock very, very quickly. What read committed does is it just brings it back a little bit and says, well, any read locks that are created, if you try to read data, it will create a read lock and release it as the moment the data is returned. But any write blocks that are created as part of the transaction will be held for the duration of the transaction. And so that's where the unit of work and this approach is very important, because as you can see, we pass on to the next handler inside of the pipeline, and finally over to the handler itself. And then only once everything comes back and is done, that's when we call save changes. All right. So that means that we're waiting to escalate those write blocks to the very end of the transaction. And that's what we want to do by default. What you don't want to do is you don't want to have to, at least unnecessarily, you don't want to call save changes somewhere in the system, then do some other reads around the system, and then call save changes again at the end, because you're going to have escalated write locks for a unnecessary duration running on that system, running as part of that transaction. So you're going to end up slowing your system down quite dramatically and potentially causing deadlocks. All right. So that's something just to keep in mind. The other thing that you'll notice here is that we do throw a transaction scope. There's several ways to do this. This is there's a little bit of an explanation here about this, as well as a link to all the different approaches to creating transactions. This is a very unobtrusive way of doing it. And so what you can see is we just essentially set up a transaction. And what this means is that should it happen that the developer does need to, for whatever reason, and there are reasons why you could have to call save changes not as part of the standard unit of work. As we saw, this is one example, but there are others where you, for example, want the database to you do actually want to make some actual saves to the database, or commits to the database, while you may be making incremental numbers and things like that. And so you may have cases where you need to call that. And in that case, it is still transactionally sound. So the transaction scope ensures that any saves that are done as part of this will, any save changes to the database will in fact be atomic, will be consistent, will be durable, and so on and so forth. Okay. As part of that ACID transaction, if you guys aren't familiar with ACID transactions, that's essentially what most relational databases will give you, and document stores like Mongo, as well as Cosmos in certain circumstances, can also give you ACID transactionality. All right, so that's obviously very important. Then the second thing that I wanted to talk about here is the event bus publishing. So this is also very important, because here we can see that we're also doing essentially, it wouldn't be considered a unit of work, but we're also, whenever the events are being published, we don't actually publish them onto the bus directly, okay? We store them in a queue, essentially, and once the transaction, or once the business logic is all finished, we go and we flush that. Okay, so this is essentially, we can actually take a look at the implementation of this. We go through the batch of messages that need to be published, and we essentially just publish each one of them. Okay, so this is actually inside. So this is very straightforward. This is a implementation for the mass transit of the event bus. We'll circle back to that later. But why this is also important is because, let's say you're building up some business logic in here, and you want to create a customer, you want to maybe do some other things, you want to publish some, create a customer created event onto the bus. And if you wanted to do that, you just want to make sure that you're not publishing onto the bus until all other business logic is essentially run. You don't want to be publishing, for example, as soon as you say publish, it goes up and it is actually there, and then you get an exception in your database from, your database blows up, and then it doesn't, and then those messages are essentially sent out to all of your other systems, right? Because that's going to lead to inconsistencies, and depending on the system you're building, those could be absolutely unacceptable. So having this unit of work or equivalent of a unit of work, we're really just having a delayed execution, is rather referred to it as that. We're having this delayed execution of the flush for our events to ensure that this happens also at the very last moment. And because we can create a unit of, sorry, not a unit of work, we can have an outbox pattern as part of this. So we can actually, for example, switch this over to an outbox pattern, an in-memory outbox pattern, or an entity framework outbox pattern. If we actually enable this, it will make sure that these events, when they are being published, are going to be persisted as part of the transaction to the database. So just to talk a little bit about that, if you are not familiar with some of the transactional concerns, and this is something that is very important when you're building systems, especially systems that you can't have any kind of inconsistencies occur, or at least the case of inconsistencies in your system can be a very, very bad thing. Okay, so medical systems, banking systems, it would be absolutely terrifying if you had transactional concerns on that front. In the past, how we dealt with a lot of this is we used to use DTC, which is the distributed transaction coordination systems, and things like SOAP used to have DTC standards that you could use. And so it allowed you to do things like, I could have a call to my system, I could do a service-to-service invocation to another system, I could maybe even publish events, and I could link all of that onto a bus, and I could link all of that as part of a single transaction. But what ends up happening is that only really worked when everything was being hosted on a single machine, and even then it was a big bottleneck. But if you had to actually distribute out your different applications and between the different service calls onto different machines, and you weren't doing this, you were doing this in the cloud, for example, if you had a DTC, and the cloud typically does not support DTC, but if you managed to do it on a server that you were managing, and you had it across the network, so different components were across the network, it can slow down that system. I think that some of the stats were in the region of 270 times slower. Okay, so distributed transaction coordination is just not a possibility these days when you're building out systems. And in fact, none of the cloud providers provide any kind of DTC for that matter, and that's very intentional. And so you have to fall back on other approaches. And so the first approach that we can talk about here is you can just not worry about it so much. Okay, so if we were to flush all our events onto the bus and we were in the cloud and we were using Azure Service Bus as an example, the chances that Azure Service Bus is not available in that moment is very, very, very slim. Okay, and so we can just rely on the high availability of infrastructure to deal with this, which is actually what we've noticed most teams do. But that could also be unacceptable, because if, for example, there was an issue there was a configuration issue with the bus, that could be a developer mistake, or for whatever reason, we have actually heard of cases where certain availability was not there for a period of time. You could end up with a lot of messages that don't make it out of your system, and that could be an absolutely unacceptable state for your application. Because of course, if those messages are not published, the database has been updated, and but the other systems haven't been notified. And so you could have, for example, orders in the system, but no waybills created, and there'll be no delivery and no invoicing and things like that. But the orders were in fact created, and maybe that's acceptable, or maybe that's not. But in some systems, that would absolutely not be acceptable. And this is where when DTC is not an option, you can fall back on things like, for example, an outbox pattern. So what the outbox pattern allows us to do is, if you've got the two resources outside of your system, which is number one, the database, and you've got the service bus, when we want to publish these messages, what we can do is, if we wanted to send them to both the service bus and the database, whoever goes first, if the second one in the order were to fail, the first one did succeed, we can't really fix that. And you can obviously sort these things out with rollback events and things like that, but typically that requires a lot of extra development. But ultimately, you've got a case where if you don't have any kind of contingency system, you could have a lot of inconsistency. And so what a outbox pattern allows us to do is allows us to bring, for example, the publishing events, it allows us to actually bring that into the same resource. So we actually store the events in the database as part of the transaction for the changes we made, and then we pull them out, and after the fact, we pull them out after the fact, and we send them over the bus. All right. And so that is, if you're not familiar with an Outbox pattern, it's absolutely worth keeping in mind. And we've got a very easy way to get that in place. We can just basically take this setting, switch it over to entity framework. I think we may have to actually, we can just see if this will set it up for us. We may have to just specify whether this is, yeah, it looks like there was some warning there, but we may have to just specify whether this is, what kind of database this is actually using. So this will go and set it up for the entity framework and actually wire up the Outbox pattern inside of, I think we might have to change some other things here. I think the warning would probably ask us to change out of a in-memory messaging system, or at least specify an actual database type for our entity framework. So I'm just going to leave that off for now, just so we don't cause any problems for ourselves. But that's just to give you an idea. If we wanted the Outbox pattern, if you're using a real database and you're using a real bus, like RabbitMQ or Azure Service Bus, that Outbox pattern is already there and ready to go. So that's obviously very, very important. That's why I wanted to spend a little bit of time talking about this. Okay, so we've gone through, if we just go back here, we've gone through these behaviors. And as you can see, what these are ensuring is that all of these will happen, okay, for the request. Now, one thing I can just mention is that the unit of work would only happen for where this request type has iCommand on it. So queries will not automatically call save changes, and commands will automatically call save changes. And so we don't actually need to typically, so maybe a better example over here is we don't need to call save changes. So we don't need to tell the system that we need to save changes. When we change the state of an entity within the system, once we exit, every developer can know that once we exit all of the business logic, we have pretty much a guarantee that those changes will be saved as long as it came in through a command. Of course, if we wanted to make state changes through a query, you'd be fundamentally violating the CQS principles. And so that probably, to call save at that point would be an absolute anti-pattern, and you'd basically be doing something quite dramatically wrong. So commands are responsible for mutating the system, and queries are responsible for retrieving information from the system, and they will not mutate the system. So another thing to look out for if you're looking for things through Google is CQS and CQRS. CQRS is usually where you take the CQS principles and apply them in quite a dramatic, often, well, it doesn't necessarily need to be dramatic, but in a more substantial fashion throughout your system. So CQS is really just the principles that CQRS is built upon. Okay, so we've covered the dependency injection. We've taken a look at, this is where the business logic is. As we discussed earlier, when we take a look at the domain, we've got our repositories inside of the domain layer. And the way that this is set out over here is that the repositories themselves, the implementation will be inside of the infrastructure. So from an infrastructure perspective, we're going to implement the repository, and this is a entity framework. So there's the connection to entity framework is on this DB context. There's Microsoft Entity Framework Core. This DB context over here is essentially what we're wrapping around with the repository pattern. One could easily swap one could essentially, not necessarily easily, but you could essentially swap this out. Instead of using entity framework, this implementation could be around a Mongo or a Cosmos. Okay, whether you'd be able to still pass in certain expressions and certain things, oftentimes that comes down to whether the technology supports it. Okay, so certain things you might have to do some clever workarounds. It depends how you want to approach that problem. But this is obviously very important because here we've got the repositories. Here's the actual implementation of the customer repository. A lot of teams we've seen that maybe they have this generic repository approach. The generic repository approach has quite a couple of problems, and that's why we actually have, you have obviously a base class, but then you have a specialization of that for the specific aggregate that you're dealing with. And so if we wanted to have any kind of specialized queries and things like that we may want to do as part of the repository, we could implement the technology related aspects inside of here. So that's just to cover a little bit of how the data access works. It's all inside of the domain. And the reason this is inside of the domain is because in a DDD world, as well as in non-DDD worlds, your domain should be able to keep itself in a valid state. And to do that, oftentimes, if one aggregate changes, it may need to cause changes on other aggregates. And so having an ability to access the data from the domain to ensure that those rules are in fact implemented is very, very important. And that's why we've got this over here. So the separation is very, very clear. We've got a 100% technology agnostic domain layer, which is able to then speak to our infrastructure through the dependency injection, okay, which is what we were discussing earlier. If we took a look at, let me just actually hop into, well, let's just take a quick look at what I want to look at now is it's a DB context over here. So the DB context for the EF This is all very, very straightforward and vanilla, but one thing I wanted to point out here is this, and this is really when we're talking about keeping the domain in an invalid state, this is very much this is a very useful pattern to apply. This is essentially the domain events pattern, which is this is the Jimmy Bogart style of it. I'll get into that in a second, but the domain events pattern is a fantastic way for us to ensure that whenever we make certain changes in our domain, that an event is then published, okay, and that event will be handled by some kind of a event handler or a manager inside of the application layer. All right, and so we can then ensure that if we wanted to, for example, instead of, let's say that there was some additional stuff that needed to happen inside, whenever you create a customer, there's some additional things that need to happen. We need to do some validation, or not some validation, but we need to change some other aggregate in the system, like I'm just trying to think of an example, and nothing really comes to mind, to be honest. But if we had to make some other change to another aggregate, like let's say we wanted to activate reports, and we wanted some other entity in the system to be notified that it has an additional report that got activated. So that's an example. So we had to increment a counter or something like that. What we could have is we could have a domain event which publishes a report activated domain event, which could be handled by a handler in the application layer. And we wouldn't necessarily need to write that logic inside of, if this was the activate report logic, we wouldn't have to write that here, okay? And that's very, very important, because what that means is that if you have, let's say, the same logic that needs to happen in different use cases, which is absolutely something that'll happen in a lot of software projects. Whenever that same logic needs to occur over and over in different handlers, you really are faced with two options. The one is that you actually create a service for that, and you bring that same logic into some kind of an application or domain service, which you can absolutely do. But the disadvantage of that is that you have to remember to call that as part of your handler. So if that logic has to happen in 3 different places, then you have to remember to call that logic in those 3 different places. But with the domain events, and I'm going to show you guys an example of that shortly, what the domain events allows us to do is to publish those events directly out of our domain. And then those can be handled in other locations as well. So let's go and quickly create a domain event, and we'll take a walk through how these are getting dispatched as well. So if we created something here, let's just call this the customer created domain event, okay? And on this, we can add a property called customer, which will be the customer itself, okay? And I can just position that over here so that we can see that this is really coming out of that. And we can just run the software factory execution. And what it's going to do is going to create us our event, which is very straightforward. Here you can see we're using a constructor for this. One thing that I can mention is that we tend to, if you want to err on the side of caution, you should use constructors for creating objects, including entities. There's a little bit of a DDD principle as well. So in DDD, you will absolutely use constructors to instantiate classes, or at least your entities and your aggregates. But what this does do is it does protect against bugs, because if you're using the anemic model, and I can show you a good example of that, little digression here, but if you are using the anemic model like this, if for whatever reason there was another attribute that was added to the customer, like if they're active, so is active, which can be Boolean. If we rerun the software factory at this point, I just want to point this out. If we had to apply that, and we came back here, you'll see that this code doesn't break, but is active is actually there, okay? And so if we were constructing this customer in a few different locations in the system, which is something that can absolutely happen, we could easily forget to add this here. And I'll show you if we go and we actually switch this over to a constructor, how that protects against that. Okay, so we've got this domain event, and I wanted to just point out here. So the domain event will exist inside of our events over here in the domain. This is it over here. And if we were to just see where it's being handled, we've got an event handler over here called customer created domain event handler. And this is essentially got the going to take in our domain event. This is the notifications coming in, and we can do some logic in here. So if we wanted to, we could inject in the product repository, and we could go and do some panel beating on the product if we wanted to. It doesn't really make sense in our domain, but just in case we wanted to get an idea, we could go and actually do some implementation here and do that, okay? But what I can just show you as well as part of this is that this is how the domain events are dispatched. So I'll show you how they're added, and then I'll show you how they're dispatched. So we'll get in, let's rather go the other way around. If we wanted to actually dispatch this event from, let's say, the customer. So if we went into the customer over here, we can create a constructor, okay? And we could publish so we could say domain events, Now this is how it's published, and I'll talk about this a little in a bit more detail. We can add a new domain event called new customer created domain events over there. And now we have pretty much a full guarantee that this will, if this customer is created, this will in fact fire. Now, the one thing that I can say is that this is, you don't necessarily want to do this like this, because EF will actually use this and you'll end up firing this domain event all over the place like this. So just keep that in mind. We can't do it like this. What we'll probably have to do is we'll have to actually go and switch over to creating a constructor. And we can say here that we want this constructor to set, let's just say, the following fields like that. Okay, let's just run that so that we can fix this up. And we can come back into our code. Yep, there we go. We don't need, yep, this is for EF. Okay, so there you can see we need an empty constructor. It's protected for entity framework, but here is our actual constructor. And we can once again go ahead and do this properly and say domain events dot add new, and we can set it up like that. Okay, so that's obviously very important. Is of course, if you end up calling this as part of anything that your infrastructure is calling, for example, with entity framework, you can create some very interesting cases in your system. But this would ensure that if we create our customer, that the name, surname, and email address is set, but it also will absolutely dispatch this. So if we're creating the customer from multiple locations, here's just one of them. We'll go fix this up shortly. If we're creating the customer from multiple locations, we have a guarantee that that domain event will be fired and that we will end up executing this logic. And the way that we can guarantee that is when the save changes gets called, and this is, so we've talked about how you add it. For these to be dispatched and for us to guarantee that in fact those domain events will end up getting handled, it's done in this approach here. Now this is actually, if you guys take a look on the internet, you can just, on the Lost Techies blog by Jimmy Bogart, he's got an entire article that's dedicated to domain eventing and the different approaches. And you've got a static version and you've got a methods approach to doing it. And this is, of all the different approaches that you could take, this has to be one of the nicest, most testable approaches that's out there. It's also the one that he recommends. And what it's essentially doing is it's linking, and this could link in with any infrastructure. It doesn't have to just link in with entity framework, but we know that any command that goes through the system will in fact call dispatch events. And so the domain events will, through the change tracker, check if the entries has an iDomain event on it. If it does, it'll fetch them out, get the first one that is not published. If there are none, it'll break because we're in a while true. And if it does have one, it'll just set it to published and then publish it. Okay, and so that's obviously what that means. It's just going to go in a circle and essentially handle all of these. So each time it publishes, and this domain services is, we can just take a look at the implementation over here. You can see all it does is it really just dispatches stuff onto the mediator. So it goes and this is all very standard as part of the Jimmy Bogart style with the mediator pattern. So there you can see we actually publish this as part of that. And this is, by the way, not a request. This is a notification. Okay, so you won't end up multiple firing things like the save changes and stuff like that, because this is not a request. Okay, it's just a notification. Right, so that's obviously a very subtle nuance, maybe something easy to trip over if you are trying to use a unit of work pattern and the mediator pipeline. If we wanted to just fix this up quickly, we would really essentially go and map this to the operation, which would be the constructor over there. And this should just go and fix this up for us. Yeah, so there you can see it just switches over to creating our entity like that. And there we go. So now it's just going to use the constructor that we set out, pass in the request information and add that over there. And now we have a guarantee that this domain event over here will be handled over here as part of that, as part of our create. Okay. So yeah, so that's just a little bit of a high level on the domain eventing pattern that exists in this architecture. And you can see that obviously we can switch over to constructors. The one thing about the constructor here that you can see is, if I had to go change my constructor at this point, this is actually a great example of where that bug comes in. If I wanted to change this constructor and I wanted to bring in the is active, take a look at what happens. Okay, so we're going to, let's just double check this. Yeah, okay, so you can see what it's doing over there. It's like, okay, you've got this constructor, but I don't really know what you want to do with that. And so we're actually going to immediately get a breaking change in our system. And so this is where not being anemic, okay, so to put it in contrast, an anemic domain model, just by the way, is really where you're allowed to hit these setters. Okay, and so you can do things like, let's just go to our products like this, where you can just set them like that and you can construct things. And so this is obviously, if anybody is interested in DDD, this is starting to head into that territory. Obviously, you can follow just some of these principles without going full-blown DDD, can save you a lot of bugs. To give you an idea, when we DDD is a little bit elusive, just to talk about it just for a second. It's a little bit elusive at times, as in I was on 2 projects that we thought we were doing DDD on. And it's only when I went on a course with Vaughan Vannon on implementing DDD that I finally realized that we weren't actually doing proper DDD. And when we realized what we were supposed to be doing, we ended up rewriting one of our systems in a DDD approach, which was a rates engine. So quite a complicated system, and it really simplified that system dramatically, and we were able to fix a lot of the bugs that were there as part of that refactor. And then all of the future systems, what we started noticing was that whereas previously, when we were doing things in an anemic model, we had about 50% bugs on the front end as well as the back end. But when we were doing DDD on the back end, what we saw was there was a dramatic drop in the bugs on the back end. And so the ratio actually fell to more like an 80-20. So we had the vast majority of the bugs were in mistakes that we were making on the front end, and very, very few bugs were actually existing on the back end, because the way that DDD structures the code base is in a way that it's very hard for bugs to occur. And it also makes sure that everything is very, very deliberate. And yeah, and one of the major rules there is that the domain can never go into an invalid state. And so it protects the system very, very much as well. So you never have this kind of invalid state problem that can occur a lot easier in an anemic model. Okay, so that's obviously just a little bit around this. We can, if we wanted to fill this in, we could just maybe just set that to true, and I can just tell this to ignore itself for now. Or we could go and actually we could go handle this and actually pass in whether it's required or not. I mean, you wouldn't want to do this. Let's be real about it. You wouldn't want to do it like this. You'd probably say that the is active. If we're going to do it, let me just fix it up. Go back to setting this to fully. And we would probably end up in doing something like this. You'd probably just say is active is equal to true. That would be the default. You'd probably do something like that. Oh, I see that this is, we did forgot to ignore this. Oh, shit. All right. So the domain event would go in here, add new domain event. Should have paid attention to my software factory there. And I can just set this over to intent managed mode. And I'll just put it into merge mode for now. Okay. Or let's just put it into ignore. There we go. All right. So that's just so that it doesn't delete that code again for us. All right. Okay, so other things I wanted to just show you guys here is if we opt into our eventing. So let's just talk about this a little bit. When it comes to multiple, like let's say you're in a microservice architecture, or you're just dealing with multiple systems that are integrating together, you really have 2 typical ways that one integrates systems together. And the first is service-to-service invocation. So that's where I make a service call. So let's say that there's a RESTful API that exists. That RESTful API, I can hit it whenever I need to, and from the other system through an HTTP client or anything, something like that, and I can retrieve information from that system, or I could even try and make mutations on that system. But the general problem with service-to-service invocation is when you're doing queries, it's fine, but when you're trying to do mutations, you could very, very easily end up with transactional concerns. So a simple example is, let's say I wanted to create my invoice, all right, but I wanted to go fetch the price of a product from the pricing system. Okay, that's quite safe for us to do because we're fetching information. But if, for example, when the invoice is being created as part of, let's just say, this function over here, if I had to inject in a service proxy to do a service-to-service invocation with let's say the delivery system, and I wanted to create a Weibull, and I said here, create Weibull as part of this. Now, what will happen is this transaction will start, it'll come in here, it'll call that other system. That call to the other system is a transaction. which will complete, and then it will return back, let's say it's successful, and then we try to save changes, and for whatever reason we have a constraint in our database that has been violated or something else that's gone wrong somewhere, and it will explode, and so the transaction won't actually be saved in the system, and so we've got inconsistency again, because that external system essentially has the waybill has been created, but the actual invoice on this side has not been created, or the order or whatever system the transaction that was trying to save on this side has not actually been saved. Okay, and so when it comes to queries, we know we can do queries quite safely because there's no mutation in the other system. But if we want to mutate, this is where a bus is a much more preferred approach. As we discussed, we could even put in an outbox pattern with a bus. Technologies like mass transit support an outbox pattern, and so we can have guaranteed delivery for the systems. Of course, if you are doing things like outbox patterns, you are going to have idempotency on the receiving side, which is quite important to keep in mind. But when we want to do mutations, the reason that you do it through the bus is because we can ensure that the message is delivered, okay, or at least it's published. We've published the message, and that message can get consumed asynchronously through the other system. And if there are any errors over there, that can be put in a dead letter queue, or the developers could basically block the queue up if you want, and the developers can get down to fixing that. Typically speaking, you'd probably put it on a dead letter queue and then reprocess it once. You could, if there was a bug, that bug could get fixed in that other system, and then the systems would go back to being consistent. So because it's asynchronous, the term here is a eventually consistent system. All right, so we're saving stuff locally, we're publishing events, those events are getting processed by other systems asynchronously, and so the state and the changes of the system are occurring. Eventually all systems will be consistent with each other, okay, as opposed to trying to put everything together through a DTC. All right, so I'm just going to quickly show you guys the stuff. I do know that we're a little bit short on time here, but if we wanted to, for example, have our product created, let's call it product created event, we can actually map this directly from our product itself. So, or actually, no, let's just do it on the customer, because that's the one we've been playing with, customer created event. I can go here and I can say map from this domain, select my customer. I can say these, well, actually, I want all of these fields that I want to include. And I can say that this will be published as part of this. And what this is going to do now, as you can see in our handler, and this is the last thing I wanted to just take you guys through. So of course, there's just fixing this up for us. I don't think I pushed save on that file. That's probably why it's doing that. And we've got our event bus, which is over here. Okay, we do need to set this to, let me just check. It should be set to a, let me just set this to fully over here, because we do want to inject this. We're doing it a little after the fact. Oh, sorry, wrong side. Let's check on the, try to merge first. No, doesn't seem to be happy with that. Let's just do an ignore. Oh, sorry, a fully. There we go. Sorry, been a long day, guys. All right, so we're getting this across here. Just want to check the merge. Yeah, so if you put in merge mode, that's perfect. So if you guys aren't familiar with this, we can put in merge. It's going to add that over there, and it's going to add that over there. And we've got now this event is going to get published as part of this. The reason that this is automatically figuring all of this out is because we're looking at the name of things, and we're saying, based on the information you've given us, just from a design perspective, it's pretty logical what you're trying to do here. If a customer gets created, we're going to want to publish out the customer, and we're going to want to map that. But what is important here, and the last thing I wanted to point out, is that the I event bus is injected here, and this is a just an interface that you could have any bus talk to. So this publishes events. You could have, this is mass transit is wrapping this right now. You could have Dapper wrap this. That's the distributed application runtime. You could have actually more a hard implementation of Azure Service Bus, or Event Bridge, or SNS or SQS, and all of those different things. You could actually implement it in any way you want, but ultimately your business logic, coming back to the clean architecture, is independent of that, which makes this very, very easy for us to test, and it would not need to change if we wanted to change our bus technology. So guys, there's a lot of stuff that I could take you through beyond this. There are lots of little other nuances that can be pulled out and explored, but I'd like to just stop there, and I'm going to pull up the participants window over here so I can see. You guys can just put up your hand, and I will enable that you can ask a question. I'd like to take any questions that anybody has at this point. All right. Cool, guys. Well, I assume then that probably covers everything. I hope that was informative. Yeah, I would have loved to grab a couple of questions from you guys, but thanks very much for joining. And we'll obviously be holding webinars as frequently as we can. We'll also maybe send out a poll to see whether there's a request on any particular topic that you guys would like us to cover. So just want to thank everybody again, and wishing you all the best for the rest of the week. Yeah, and catch you for the next one. All the best.